exciting presentation by Arnab. So we made this one just half an hour because Arnab will actually demonstrate it tomorrow in a workshop. So, so between Arnab and then Patrick and Lale, we must just finish within an hour and 15 minutes. So if you steal a bit of their time, you can sort it out tonight over wine. So, okay, so thanks, Arnab. Over to you. So.
Okay, thank you, Paul. Yeah, I'm on. Okay. Excellent. Okay. Hi, everyone. So as Paul said, I'm going to demo certain things here today. It's a very risky job doing this here. Why is it risky? It's risky because it's a demo of a live system. It's even more risky because it's to do with AI, which is notoriously unpredictable. And really, what Bayern is trying to show that we can try to make AI operate within the bounds of predictability as much as we can. So that's I think, a key advantage of Bayern, which I'll try to highlight through this presentation. So before we get into all that, I just want us to take a moment to remind ourselves of why we are doing Bayern. So really we're trying, and it has been spoken about before, so we're trying to move from the monolith to small reusable building blocks. Reusable building blocks, every word is key there. So we want to have building blocks that are standardized and that can be put together to create applications, larger applications. That helps with interoperability, and that helps with the single one-line mission statement of Bayern, which is to reduce the cost of integration. So that's what we're trying to do. In that, again, we know the Bayern has this landscape, and we know the service domains. This is an older version of it. But anyway, the idea here is that we have the service domains, the small reusable building blocks. And for each of these service domains, we have an API spec. We have been publishing API specs for a good few years now, I think since 2018 actually. And the level of detail and the quality of these specs have gone up over time and is still improving. And it will improve even more throughout this year, as Lale and Patrick will show, as we make the Bayern model AI ready, which means we are trying to go from a purely conceptual model, a reference architecture, to a standard, something that is logical, that is implementable. That's the journey we're on. So I just want to show that here. So we have the conceptual layer, which is the Bayern model, most of the Bayern model as we know it today. We started publishing API specs, which is trying to get to that logical layer, and the quality of that needs to get better, and it is getting better. It will get better this year. But then what I'll show you now is how do we take that logical layer into the physical layer. And that we're going to show you using what we call the Agentic Banking Studio. So a very quick note on this, and Lale and Patrick will expand on this. So part of the reason for us to try and create running software from the Bayern standard is to actually prove that the Bayern standard is good enough to write code from. So that is part of the reason why we are doing it. So it's an adoption tool, but it's also a way to prove that the standard is good enough to create code or running software from it. Not just code. Code is a very loose term, I feel. We can go to ChatGPT and get some code. But this is running software. By that I mean it has the database, it has the vector DB, it has the AI context, everything. So that's what we're trying to do, and in doing so, we announced the Agentic Banking Studio in Chicago last year in November. And those 3 points up there is really what it does. So it has 3 pillars, 1, 2, and 3. Pillar 1 what it does is it helps you identify buy-in service domains, service operations in existing code. We have done it with COBOL code, with a sample COBOL repository so far about card transactions, but we can also do it, we can identify buy-in service domains from documentation, from business requirements, and we will have a workshop on this with Rizwana tomorrow, where we'll demonstrate this in more detail. The second pillar is very exciting as well, is where we take an API specification from buy-in for any service domain, an AI-ready service domain to be precise, and then we generate software from it. What do I mean by software? We generate a running container, which has got all the service operations, the API endpoints. We generate the MCP connectors for it, so agentic workflows can work with it. We generate the database schema from the buy-in BOM. We generate an AI context, which makes the service domain AI ready. Means you can run natural language queries on any transaction that goes through the service domain. So, and Hans put it really well, I think in November. I didn't realize the importance of that statement, but I do now. The idea here is we take the standard and we generate a running application, and we do it again and again and again. And that's by the click of a button. And that's the idea here. So the deeper the standard becomes, the better the quality of that running application. By no means am I suggesting that that running application is production ready. It's not. But what it is, it's a very good starting point. It has got security enabled on a standardized, fully buy-in compliant, and you can modify it to meet your purposes. That's the idea. So we generate the microservice, we generate the MCP connectors, and finally what we do is we link these MCP connectors in what we call an A2A workflow. So A2A is a protocol, I think less than a year old now, released, led by Google, and it allows you to connect agents together. So these agents interact with each other to achieve a business outcome. How do they interact with each other? They interact with each other following a buy-in business scenario. That's how they interact with each other. And that's where we put the guardrails in buy-in on the AI agentic workflows. So that's the idea. Now, what I'll say as well is that whatever we are trying to do here is pushing the boundaries of what's possible with technology. So it's not necessarily always acceptable within a bank in terms of security. But that's not the point. We're trying to show and prove what we can do with technology. And also, we're trying to show what is acceptable for a bank today. It might not be, not everything might be acceptable today, but maybe in the future it will be with the right guardrails. And we are trying to put that guardrails in place, those guardrails in place. Okay, so what I will do from here on is move to the actual tool. Bear in mind that this tool is not live yet. So we are supposed to put it live this year. This month, not this year, this month. But you can see we have deployed it, but we haven't tested it fully enough. So this is the document analyzer. The idea is you put in your business requirements document in a PDF. You run it with our buy-in AI context, and you get an outcome, and you will get things like this, like strong matches for service domains, service operations, and business scenarios. And tomorrow we will go into the detail with the real use case that Standard Bank created with Rizwana, and then we will show how that actually works, how that compares with us doing the analysis and so on. So I think that's one thing. The other thing I want to show, and I won't run everything here because it takes time. I have been running it all morning, by the way, sitting there. So these are all run from today. Things we can also do is, this is a sample COBOL repository, which is a card application. It captures card transactions and all that. So we can do things like buy-in analysis on it, say which service domain, service operations are likely to be related to what's happening here. And then we can generate code in several languages. Here you see Node.js. We can do, I think, .NET, Java, something, Go, etc., etc. Really, what languages we do is immaterial. We can do any language we want with AI. So, but is this enough? This is not enough. So what this is we are saying we can generate code and we can identify service domains. Our next step, what we're doing next, is we identify the service domains, we generate the code, and we link the code to the right service operations and give you that framework where from that code, the logic we extract goes into service operations in the generated microservice. And then you can modify it, update it, and so on. So that's the next thing we're doing. Now, one of the questions that came up, I showed it to a bank recently, and one of the questions that came up is, here you are looking at one code file of COBOL. Yes, that's right. I have opened it in VS Code and I'm looking at one file, but actually in this area, you have the functionality to put in a whole load of files in a zip, and it will do it on the whole thing. It takes a bit longer. So that's the idea. Now, the second part of it is, the second pillar, we looked at it, the microservice generator. So what we do is we take a buy-and service domain. So here I took investment portfolio management. Can't read all of it. Then we have the MS generator. We have things like Docker build and stuff and cloud deployment and all that. So what it does is it takes, maybe I should show you this, it takes a buy-and API spec, a YAML, and basically from that, this API spec not only has what is the control record, what are the BQs, what are the service operations, it also has what is the related business object model. So it generates the database based on the business object model, it generates the service operations for the microservice, and it generates the whole container for each of them, and then you can run it. You can run it, but also you get the source code. So every time you run it, you can get the source code. Now, this is a visual view. You drag and drop components and run it, and this is what's going live in this month. In the future, what you will have here is a chat. Obviously, everything is a chat. So in this chat, you can have the code, and you can chat with the generated code to update its logic. And we have built it already, the back end. It's not in the front end yet, and we can't release it right now because it's not integrated. And also what that will do, so right now, today, we generate code here, let's say, with Node.js and Python and support MongoDB. Right now, we support only MongoDB, but soon we will be supporting relational database like Postgres, MySQL, and more. So that's the idea. So we can generate in any language, any database, and all that. So to give you an idea, I have been doing this all morning. So you have databases like this is MongoDB, and you have data. You can see these are all fields from the Bayern BOM, really. So we have taken exactly the elements in Bayern to generate this. So that's one thing. Then what we do is we have another area where we generate the agents. So agents, it's not quite true. We generate the MCP connector here. So what we do is we take the microservice as per the Bayern standard, and then we generate an MCP connector. In very simple terms, what an MCP connector really does is it makes your microservice be able to communicate in natural language. So it can communicate with a human being, it can communicate with another agent. So that's the idea. So when I say it can communicate with a human being, what does it mean? So I took investment portfolio management and I generated the service, and then this is the kind of thing you can do. So you can initiate investment portfolio management activity for a customer using example data. I said example data. And then it initiates all that. And then, I can say now initiate a trade on this investment portfolio with sample data for all fields and all that. I made a mistake even here, said current account. But it actually initiated a trade on the investment portfolio. So you can talk in, you can give it instructions in natural language. You can also speak to it, in fact, and that works as well. So that's the kind of thing you can do. And the idea is that this could be used for testing, but this could also become the user experience for a customer of a bank. I mean, a customer of a bank surely in the future will chat with it, not go through fixed apps. So, that's the idea. So natural language communication. So I think those are the two key things. The third thing you can do with this is, what is very interesting here is that, so you can, this is a business scenario that Lale and Patrick defined 3 months ago, which is around the standing order. So an SD here is the session dialog, service domain. The CA is current account. The PO is payment order. So what happens here is you do a session dialog initiate, a service operation, a session dialog product or service initiate, then you do a current account retrieve, a current account payment initiate a payment on the current account, and then payment order initiate. So a customer can go in and ask to set up a standing order with their bank account, and that standing order will be set up, and a first payment will be made using this flow. So this flow is called SP or whatever, 26227.1, not a great name. But if I go here, no, sorry, not go there. If I go to the application chat, I can select that particular one, and some of these things are a bit slow, so I didn't want to make everyone wait for it, but you can see it is calling an agent here, and in a way it's good that it's a bit slow because you can see what's happening. So you can see that it's calling the agent workflow that I created, and what it's doing behind the scenes is initiating a new session dialog and is initiating the product. You see, calling tool session dialog initiate. It came and went quickly if you saw it. And now it's calling another tool, which is session dialog product and service initiate. So that agent is calling these tools. So now what it says here is quite small print. Maybe I can make it larger. Let's see. I can make it larger. Yeah. So the session has been successfully started. The necessary product and service invocation for your recurring payment setup is in progress. To proceed, I need your current account facility identification. Now, if this was a real use case with a real customer, you would have got their current account facility identification to some other step. We haven't modeled everything here, so it's asking for the current account facility identification. And I have one here, I think. So this is just an ID for the current account, and let's see what happens. So it's again targeting that agentic workflow, that A2A workflow. With any luck. Okay, so it now comes back and says, this is an account I've set in the database. It says, this is my account. It has got 1,250 USD in it. And then it says, please confirm if the account details are correct, and if so, provide the payee's name, account number, identification, all that to set up the standing order. This flow has been modeled to service a standing order setup, so that's why it's asking that. And we saw the flow kind of before. So what I can do then is I can go here and say, instead of typing it in, I'll just copy and paste. I say, okay, set up a recurring payment of 100 USD to Nigel Nobody and Nigel's account number. Oh, see, I said Sarah's bank name. I don't know what will happen. Let's see what happens. It should have said Nigel's bank name is that. Maybe it understands that. Maybe it doesn't. So maybe it fails. We'll see. But that's the advantage also of advantage and disadvantage of having natural language, that it should be able to interpret it, but it might interpret it incorrectly if you don't have the correct guardrails in place. So anyway, this has interpreted in the way we wanted it to. So, your recurring payment has been successfully set up as requested, payee name, all that, and all of these. If I go to the database, it's not the correct database, it's on my local host. If I go to the hosted database, there's some new records in here. So 11:53. Okay, so this is UK time, 2 hours behind, 11:53, 13:54. That's kind of where we set it up. Nigel Nobody, all of that stuff, 777, all that. What we're trying to say here, and obviously I haven't shown you every single detail of the process, but the idea is you take a buy an API spec that is AI ready, you create the whole microservice, you create the MCP connector, and you create an agentic workflow, A2A workflow based on the buy and business scenario, and you have the basics of a running application. You might want to update it with specific logic and so on. But in Bayan as well now, we are defining a lot of the event-driven workflows, what triggers what. If I make a payment, I need to apply fees, things like this. And the more we define in Bayan, the more this starter pack can generate in terms of code. And the idea again is that in here, we are, see, I've got loads of downloads from today. We're generating these microservices. These are standard, well-architected Node.js code structures, any language code structures that, you know, programmers can open VS Code and they can look at it, update, do whatever they want. So that is pretty much, you know, what is there here. I will just go back to my presentation again. That's what it shows here. So just to highlight, you know, some of the key features of the generated software, I think I kind of spoke to it anyway. It creates, you know, standard structure for the generated code following all Bayan principles. Service endpoints aligned with the Bayan service domains. You know, database is modeled as per the Bayan BOM. The generated service domains are AI enabled. You can write natural language queries on it. You know, you can find out. I was just speaking to Patrick at lunch and he was saying, can we find out, you know, if a customer is making a lot of payments out of their bank account to a different bank, are they going to go for some reason? Maybe we can offer them a good rate on a fixed deposit product, things like this. So you have all of that customer activity intelligence or data being stored as vectors on which you can write AI queries to get that intelligence pretty easily. And all of that is being provided out of the box. It can be built out of the box. And what I've said is here is we'll soon support event-driven flows as well. So again, we have the backend for it. We haven't integrated it here. Future of where it's going. So we'll support multiple languages, multiple databases, vector DBs. We'll support gRPC. We'll support event-driven flows. And we're also going to provide a lot of support on security and performance. So Paul raised this issue, I think, a few months ago about are we ISO compliant? And there are 5 or 6 ISO standards to comply with, which are very, very rigid. It's great, because that's the challenge we want to overcome. You know, we want to get in there and make sure this is fully secure, and everything it generates is fully secure. Right now, we have authentication with bearer tokens at every level, at the A2A level, at the MCP level, at the microservice level, at, you know, database data is encrypted and all of that. But can we take it to a point where it complies with all of these? And yes, we can. We're working on it. Also, we have tools in here which allow us to do security, like performance, like penetration testing, performance testing, and all that. The thing is, this system can generate the backend software. So when we need a module here, like if we need our own analytics, we can generate it for ourselves. So this is a really powerful system. Another topic I'll go to, the application landscape mapper, might be quite interesting, slightly different topic, nothing to do with code generation. So one of the things we're looking at is, can we get a tool where you can map revenue, cost, risks, any attributes you want to the Bayan landscape? You know, whether it's headcount, whether it's, you know, how much it costs to run a system, whatever. So again, as part of the studio, we have this application landscape mapper. So you can, let me see if I can, oh, it's not, okay. Okay, so you can pick any service domain you want here, and then you have these actions, and you can configure attributes, like you can configure headcount, technology stack, business priority, and all that. But you can also create your own attributes. You can add whatever attribute you want in different formats. So you can add these attributes, and you can store it against any version of your landscape. And then what you can do is you can do simple searches, like you can say headcount, show me applications with small headcount. You know, and then it highlights them in the landscape. But also, and the power of it is you can do AI-based searches. I don't have enough data here, but you know, you can do things like, you can say, which systems in my landscape cost below this amount, or, have a low risk and things like this. And that would be able to highlight, the systems in this landscape. So that's the idea of this landscape mapper, that you can capture different types of data, and then you can run AI-based queries on it to look at, where your costs are, where your revenue is, where your risks are, and all that. As Hans mentioned, one other thing we're doing, again, not in this version yet, is we're integrating this with ServiceNow. So you can link to ServiceNow, bring data in through their APIs, and then basically show anything you want from there in incidents. What are the P1 incidents in a certain system? Whatever you want, you can run these queries and view it here. So that's the idea. I'm running out of time, I think, so I'll try to finish. I think one other point I want to mention here is around certification. For those of you who have been following Bayern for the last few years, we had a very strict method of certification. So anybody creating Bayern-based applications should align to our API endpoints, the attribute level alignment, like any other standards body does, like open banking or whatever. But then we found that a lot of our members found that too strict. So they wanted a certification that is based more on, let's say, what data a function accepts and what result it returns. So like service operation input-output data. And we can do that with MCPs. So one of the things that's part of this studio as well is you can take an API endpoint, you can generate an MCP, and then test how well it aligns with the data input and output of that defined Bayern service operation. So you can do that kind of thing as well. I have this slide on the API Align tool. I think the key message here is that the API Align tool, if you are starting with an API spec, gives you recommendations to map your API spec to the Bayern spec. And why I have it here is because, yes, we are talking about AI and MCP and whatever skills and this and that, but ultimately, you need to always have a good specification as a starting point. And I think the APIs still matter. They still have a place. So even if you connect using agents and natural language, which in itself might be risky, it might be not totally predictable, the API endpoints are always predictable. And so, I think Bayern having these good API specs are important. And to align to a standard, if you can align with the API specs, is always a good idea. So that stays in place. With that, I'll finish. Only thing I will say is, if you are a Bayern member and if you want to try the studio, next month, you are welcome to try it. You are encouraged to try it, and just email us at info@bayern.org. That's it from me.
Thank you, Arnab. We're running out of time, so and Arnab will be here for the 2 days, so you're welcome to just engage with him during the breaks.